Right. Hello, everybody, and welcome to this session, Corporate Investment in Forestry. We're going to take a look at the global risk, climate risk matrix. That's a lot of risks in there. And the next slide, we'll just have a quick look at who we are in forestry at Globe Underwriting. And as you see, we're part of our Donna Group. We're an agency. That means we write insurance on behalf of somebody else. And we've been writing, that is to say, insuring forestry since 2005. In addition, we do quite a few research and development projects, and at the moment working closely with Edinburgh on fire, wind damage and mapping, and more of that later. And the policies we issue are Lloyd's. That means they're A-rated, or if we go elsewhere, they'll be better than that. And the last line, we are writing insurance in over 30 countries of the world. So it's a pretty broad portfolio. This map, which some of you may have seen before, just marks all the locations where we've investigated forestry and particularly the risks associated with them. So you can see from that, we've probably got a very big data source, and one which, of course, as insurers, is probably bigger than most investors into forestry, because we are flitting all over the place with our business. And the next slide shows that, that's interesting. The next slide is actually not the slide that I was expecting, because we've changed we've changed the presentation in the last hour. So while I'll just carry on, fine. So in forestry investment decisions, we deal, of course, with financial risks, market, country, regulatory, and so on. And then we get into physical and environmental risks, which is what we do every day. We look at the perils of fire and wind, which probably account for 90% of losses in forestry investment. But many other things as well, their severity, their frequency, and so on. Now, on the next slide, we should see that we have had, there's a seat of the pants stuff, is we should see that we've had a discussion recently with a major international financial services group who put to us the problem they were facing. And I've sort of quoted or paraphrased what they're saying. We have no means to quantify returns by region, knowing the positives and negatives. What we need is a global and regional forestry climate risk matrix based on reputable modeling techniques. And it occurred to us, of course, this is actually what we do every day. We normally do it for insurers. We're often just doing it for the next 12 months. However, within our modelling, we're getting answers that would throw a lot of light on the risk being faced by a forest or woodland in any particular situation. Moving on to the next, how do we define the challenge? The investment decisions on the next slide have been grouped together. Moving on. The clouds, because most of them are problems. That's why I thought of that. But we've got the forestry that you're likely to look at on the left there, and the various aspects that you will consider when making that investment. Obviously, there's all the forestry stuff, the species, location, water, and so on. There's a normal investment risk and their discount rates that we mentioned before, country risk and currency risk and so on. But the thing we're really concerned with is the orange blob down there, climate risk, fire, drought, windstorm, and ice storm. And what's driving all these? Well, we need to quantify the impact of a warming climate on forest health, growth, and survival. And within that general warming trend that we have regional weather cycles as well. And in the next slide, we'll have a look at that. And of course, popped in the triangle there was insurance. So if we're looking about short and long-term considerations, let's have a look at on the left there, long-term climate trends. Well, as I say, you've got to live with these. There's no ducking them. We're thinking about higher temperatures, moisture content in the atmosphere, frequency of storms, not necessarily stronger storms, rainfall, which is volatile. Wetter places on the Earth's surface will get wetter, drier places will get drier. Increased evapotranspiration from crops and trees, and changing seasons, or new seasons indeed. So this is what we have to live with. And if you like, that global matrix will try and address what impact that will have on the returns. The shorter ones that are predictable for months ahead are interesting. We'll just give you a clue as to what might be happening over the next 6 months. I've mentioned the MGO there, 40 to 50 days, which is Asian and Australian monsoons. We have the famous ENSO cycle, El Nino and La Nina, which in many parts of the world, El Nino is associated with fires and La Nina with floods, but not universally. It can be different depending on where you are. And the North Atlantic Oscillation is a cycle that is worth a look at, because it's suspected this has a strong association with forestry damage. And of course, all these weather systems are teleconnected, and one affects the other. And so, you know, what happens in the UK can affect what happens in New Zealand. On to the next slide, we have some key points, some illustrations of what I've just been talking about. Long-term climate trends. You all know the hockey stick, the rapidly rising temperatures. And in this chart of the last 22,000 years, it really puts it out there how steep this increase in temperature is. And that is a scary issue. That's the thing that bothers us as insurers. But in the short and medium term, as we say, there are links between ENSO index and forest fires, the ENSO, the El Nino that I've just been talking about. And if you're going on to the next slide, you'll see a couple of concepts that I want, or I'd like forest managers and investors to consider. Probably the most important is the extreme event. These are events which are a multiple of the last biggest event. They're not linked in any way in terms of maths or whatever, but they're out there and they could happen. And maybe, you know, we've had a couple of examples of these recently, which we'll come to. The other elementary point which needs to be emphasis is we're trying to model for the future, and we're not trying to model for the past. And averages that I'm quoted frequently by forest owners and investors really are meaningless. It is about the rate of change. So in this chart, you've got whatever it is, 20, 25 years of pretty low losses on this forest investment. And then from about 2000 and whatever, I can't quite read, it's too small, we're beginning to get more volatility in the losses. And 2009, we had that huge 10% of the standing value of the forest was burnt. So you can see the volatility has risen considerably, and indeed there is a new average. So the average has moved from 0.21% of the area burnt every year to an average of 1.19%. So this is, you know, averages are pretty meaningless. Looking on to the next slide, there are management activities that you can take to reduce risk. Obviously, site selection is key. And a very simple example there is Oregon, where you can see the different forest growing regions. And that is, we've got the wet forests, as you see, on the west coast there. And if you're looking at the burn scar map of Oregon, we have a fairly low instance of fires up that coastal range, but a considerable instance of fires as you get into the dry east. So selection is really important, and you know, a tool right here demonstrated in front of you can show you perhaps where the best sites can be. The other aspect is forest protection measures, investment in firefighting and so on. These are extremely important and will protect you against most events. The extreme event probably cannot be prevented by excellent forest management, but it will make a huge difference from year to year if you can have proper forest protection policies, firefighting systems to help you. So moving on. So what's happening with forests and climates? Let's have a look at the next slide. you know the temperatures are going up. So I just picked, not quite at random, Asia as an example. So the burn scar map on the right there, which we produced through Earthbox, and a little chart of rising temperatures since the 1950s. As it happens, we've just heard about a new fire claim coming out of Thailand. So it's sort of a demonstration of the point, isn't it? And the relationship between the area burnt and rising temperatures is certainly there and strong. So that's happening, of course, all over the world. And the next slide may show us other examples. Wildfires in the States, for example, pretty progressive increase in burned hectares, but a little point there that these are not related to the number of fires. The number of fires tend to be pretty constant year to year, but the fire sizes will change according to the temperatures. Moving on, in Australia, the 110-year loss record, I'm grateful to David Geddes for this one, just showing the rate of loss across Australia up into 2020. Next slide. We talked earlier about seasons, and one example is the New Zealand, where I've just lost my own notes now. Get that back, it's all going down. I've lost your picture, Hayley, but I am going to, there we go, New Zealand. This shows that the length of the fire season is extending by about 30%, and other countries may have delays in the onset of the rainy season. So maybe these, two sides of the same coin. But certainly, I know in Indonesia, they're finding on occasions there appear to be a new dry season coming in the middle of the rainy season. So all these changes to the conditions where your plantation, your investment is happening. We mentioned in that the Nelson fire of 2019, by standards of Australia and Chile and South Africa, is pretty small beer. However, for New Zealand, it was a catastrophic event and a repeat indeed of what had happened 60 years earlier. Next slide. Just to let you know, Hayley, I can't see what you're doing, so I'm following this one now. The impact also is on not only mega fires, but windstorm, hurricanes, and which, as you see, the famous image from 2020, when we had 5 Atlantic cyclones visible across the Atlantic in September, and in that year, a record number of named storms. So all part of the weather risk. So Hayley, just to let you know, moving on to slide 20 here. Can modeling your data indicate a realistic worst case? And we believe it can, when done in conjunction with forest management, of course, and understanding the nature of trees and what you're doing in there. So moving on to the next slide, we have an image of New Hampshire long-term fire history. Now I put this in just to make the point that if you're going to use data for modeling, you mustn't go too far back in time, because conditions were very different. Recording quality was very different. And there we have a vast numbers of fires happening really until about 1960 or something, which is when new legislation was brought in about fire protection. And they set up in New Hampshire, they set up a 7-state compact to help firefight fires in the region. So you can't go too far back. The next slide has a similar example from China, where the China Forest Law of 1985 produced a marked reduction after a few years to the amount of area burnt in forestry, and you can see the drop in the green curve there around about the mid-80s that demonstrated the punitive laws that that surrounds forest managers that allow fires to happen. So you can't go too far back. But to go back 20 or 30 years will give you a decent data set that you can draw conclusions from. So on the next slide, which hopefully is 23, we have provided an example of Chile. And this is region 7, and we've done before and after the severe historic fire season of 2016 and 17. We can move that down there. Yep. So you can see there a list of fire losses. These are percentage of the area burnt in the region 7 from 2000 to 2018. So that's 19 years. And we've done 2 models. We've done one 2000-2015, and you can see that in the model results, the red grid there. And you see that we've got a regional wide mean of 0.39% of the area each year, and a 1 in 250 frequency of about 3.57%, not 300, 3.57%. If you do the same exercise, including that amazing loss of 31% in 2016-17, of course, you get totally different results. The mean loss shoots up 2.16%, and the 1 in 250 frequency is at 51%. These seem extraordinary, unbelievable levels of destruction, which I must say, I think took us all by surprise across the whole industry. There were special circumstances, and the point about this, you can see these coming. And in this case, it was 4 years of severe drought preceded the event. And during the year, there was an anticyclone stuck off the west coast of Chile that was pumping in for 3 or 4 weeks hot, dry, fast blowing winds, which just carried the fire everywhere. And professionally managed forests did in fact fare a lot better than the region as a whole. And as we said there, about 9% of value across Chile was destroyed that year. So that shows the impact of a major event, of course. And if you're thinking about what might happen in future, you can perhaps add some sort of loading. Moving on, just to show you what did burn, there is region 7, nice map of Chile. And in that top square, the burnt area as of 5th of February 2017, where the loss amounted to 31% of the plantation. The next slide shows that Chile was soon followed by the Australian fire in 2019 and 20. Remarkable again. There's a little ring around Kangaroo Island, because that was a famous forestry reserve and hotels and all sorts of things, completely destroyed that year, just gone. And the fire records show that we've got a 5 times increase in the rate of loss over the last 40 years, having just split that time period into 2. And you can see the figures for yourself, a pretty low average rate of loss before 2000 and 5 times higher, thereabouts thereafter, with potential for severe big losses. So we can use your forestry data to do that sort of exercise for you, for your portfolio, for your intended portfolio, where we can research not only from our own database, but also using earth blocks to map fires in and around your location. We are currently using about 20 years of data there, and we compare the burn scars of managed and unmanaged forest. On the next slide, we have an example for you. So South Africa, the red site in the middle is the actual location of the forest. And of course, within the rings is, can't quite remember whether it's 10 or 20 kilometer range. So we can see the environment within which you might be investing. And it can demonstrate, of course, the quantitative benefit of good forest protection. Let's have a look at the next one. Here we see the whole area. You can see the fires within the blue circle. We've got a little arrow there that points to the land cover. Now the green and the dark green, that's all standing timber, and the yellow will be crops and other other lesser things, we foresters might think. And you can see on the right-hand quadrant where the fires have been. And if you just compare those two carefully, you can see that most, not all, but most of the fires have all been outside of the managed forest area. There's a little a table on the left, which is just an example of the data that we extracted using earth blocks over that period. And at the bottom, a summary. So within that invested site, the annual burn rate was 1.3%, pretty high as far as we're concerned, but it is South Africa, compared with 3.8% outside of that area. Moving on, we can, of course, look not just at specific locations, but just go around the world deciding where it's very busy as far as fires are concerned. I should add as a footnote that I'm talking about fires because we've been using this earth blocks tool for some time, but in fact we're developing with Edinburgh a wind damage tool, which we hope will operate in a similar way. And that is valuable because wind loss data is really rare. A few people will record it, but if they're moving into a new area, we could go over that area and identify which parts have been damaged in which storms across time. So we've got an idea of historical losses. Moving on, conclusion, can we model climate change trends? I would say yes, with care. It's not just a numbers game. You know, it's about looking at the data, producing your profile, thinking that the big event, if it hasn't happened, will happen sometime. So how do we factor that into the sort of results we're getting? Obviously, some sort of loading can go in to there based on its location and severity. So the loading for Chile or Australia or South Africa will be far higher, of course, than northern latitudes, Europe or North America, and so on. But we can do that, and we feel that's something that any investor, and particularly if they're thinking about carbon and the fact that carbon has to be there for a long time, really needs to have a good grasp of what could happen according to climate change. The model, of course, is not all-seeing. We have to use any model with caution, but at the very least, it'll enable you to compare locations and risk from all the factors that will affect the survival of your forest. And as I say, if we're on the same slide, Haley, at 31, forest management has a massive effect on actual losses, but extreme events will overwhelm even the best protection. Little tidbit for you there, 90% of losses from about 2% of fire events. So the climate is changing, it is getting hotter, it does lead to extreme events. If you're looking at US now, for example, it's got some of the highest drought conditions at this time of year of all time. So we cannot take this aspect lightly. And as we say, current conditions constantly changing. That's the next slide, Haley. There are other things, of course, that are influenced by losses, and that is the pest and disease that will come before a fire or after fire and lead to higher risk as time goes by. And things like, what's the impact? What's going to happen to your rotations if there's not enough rainfall to take it through to the end of 30 or 40 years? So these are bigger questions, and some studies have been done on that, but no time to go into it here. Is it possible to dodge the worst of climate change through short rotations? Well, I don't know. If you're in Asia, you can do a 5-year rotation of something, then maybe, but that is not really what we're after. We're after long life stands of biodiverse forests. That's really what we're after, and to not only provide habitat, but to secure carbon for the long term. And just, will anything we do in the next 20 years affect our experience of temperature trends? And I think the answer is certainly no, because the carbon has a half-life of about 100 years, and that's what we need to aim towards. And that just about brings me to the end of the presentation. Yep, we can produce a global and regional climate risk matrix. It's tailored to your portfolio, the spread, the tree species, the forest management and technology. And we can show through this the range and frequency of losses, a potential catastrophic loss. As we spoke about earlier, we can load that data to show what might happen. And repeating it every few years will give you a handle on how things are changing. So thank you so much for your time. Sorry that the presentations weren't quite as smooth as we had hoped, but here we have our contact details and a recent windstorm across the UK. So thank you very much. As for questions, because I can't see any, so here we go.
Yeah, so I'm just going to read you some of the questions from the audience. We've got some time, so feel free. Okay, so one of the questions: how do you consider biodiversity in your assessment process?
The short answer is we don't, because we haven't been asked to. However, we're acutely aware of the impact of biodiversity on the risk profile of a forest. Take a very simple example. In the days of monoculture, you always had mixed species running along the watercourses, and they were a great tool to mitigate the impact to fire. Excuse me. To mitigate the impact of fire and to slow it down. But the component part of biodiversity it's not part of our day job. Although we have, we are about to start a project on this very topic around the world in Europe and China. So maybe in 5 years' time, we'll be in a better position to answer that question.
So I've got a couple of questions here about fire prevention and fire suppression. So do fire prevention measures like controlled burns negate the carbon capture, or do they just reduce the amount of carbon stored?
Well, I mean, literally it does reduce the amount of carbon stored, but the amount of controlled burns has a bigger benefit, and the bigger benefit is to usually reduce the fuel load so that you're protecting the rest of the forest, and the fuel load will be relatively low carbon content. I mean, grasses, things like this, there will be stuff in the roots that will stay there, but the surface grasses that lead to fast moving fires will be removed by the controlled burns, and that will be part of any carbon assessment under the terms of the protocol. So you would be foolish not, if you're in that, that part of the world, you'd be foolish not to consider controlled burns, although you could replace it with something like mechanical destruction of fire carrier plants and so on.
Thank you. Another question here. So are fire suppression measures not precisely one of the reasons big fires are becoming frequent, more volatile in the statistics?
Yeah, it's a great question, and of course it's a huge topic of debate on the west coast of the States, where the federal lands have been allowed to. Yellowstone Park, of course, was another example where the natural forest cover had been allowed to grow unhindered for many years, and so build up fine fire fields within it. When fire did come, it did a lot of damage, and if you're ever in that region, you'll see vast areas of burnt out west coast forests. And the reason for that lack of burning was, of course, to try and maintain a rich, biodiverse environment, which is admirable. However, there's got to be a compromise. A stupid example, but you could have so many locks on your door that nobody ever break in, but you'd find it rather difficult to get in yourself. So it's a bit of a balance, isn't it? So yes, absolutely. We need to manage our investments, particularly for carbon, in a sensible way that is a compromise between reducing the potential for a massive fire to maintaining the environment as we'd want it. As you know, no answer fits all situations. So I agree with the questioner.
Perfect, thank you. So we've got, there's 13 minutes, so we're just slightly easing into the coffee break. So maybe we'll just do one more question and then we can break for coffee until the next session starting. So last question here, is there carbon credit insurance readily available as of yet? And if not, when do you expect to see this?
Well, I'm one of these characters who's been talking about this since 2009, and and that's because it all went away back in the day, and it's now back. And as we've been discussing internally, we are now getting regular approaches by people investing in carbon projects, often reforestation, afforestation, that type of thing. So the answer to the question is in two parts. I'll give you the good news. It's obviously very simple to ensure new plantings against the investment that went into getting those trees in the ground and all the infrastructure and so on. If you're thinking about indemnity of carbon credits, that is to say, you buy a carbon credit of 2020 vintage, let's say, and you lose it in 2050, in a perfect world, you'd like to have that replaced by a carbon credit of a 2020 vintage. In other words, you would just carry on storing that carbon. So far, we haven't done that. We are very early stages of talking to the various registries to determine. I think the answer lies in how is the buffer managed and what's its legal status and so on. Because I think there are ways to work with the registries to actually develop a true indemnity for forestry carbon. In other words, like for like. If you bought a forestry carbon, you can get it replaced, ideally the same forest, same vintage if it's a big enough project. The simple way doesn't really work, and that is simply to insure the forest carbon for dollars. But the problem there is the carbon price, according to the projects and the standards that it's managed under, varies greatly, and the carbon price is beginning to move significantly upwards. So you need some sort of arbitration. No, you know what I mean. Some sort of system to cope with the variation in carbon values. If, as an insurer, you need to pay out for a loss, and to replace it, the carbon costs 10 times as much, let us say. So any more points, Hayley?
No, that's all. Thanks, Bill.
Well, thanks very much. Thanks for your tolerance of whatever you could see. I hope we could all see more or less the same thing, and the words applied to the right side. So thank you very much.